Hello everybody, this is Dr. Pennington again with another preparatory video for you. This time I want to talk to you all a little bit about the concept of unit conversions. Now some of you may have heard this called something like dimensional analysis or the factor label method or something like that, but the point is it's the way to convert from one unit to another. I'm sure all of you know about the fact there is the metric system, you know, meters, kilometers, grams, kilograms, that sort of thing, the measurement units that actually kind of make sense. And then there's the English or imperial measurement system that doesn't really make much sense at all. Pounds, inches, feet. When I say it doesn't make any sense, what I mean is it's very easy to relate 1 kilometer to a meter because the K here is just a prefix in terms of in front of the meter, just as a liter can be very easily correlated with a milliliter because that milli means something. When you look at these are from the metric system. When you look at something from the English or imperial system, you have things like inches and pounds and stones that most of you probably haven't heard of, and miles. Okay, things that you cannot correlate with each other in the same way that you can units in the metric system. And so to be able to convert between any of these, and indeed between any of these and any of these, you need a relationship between the two. For example, there's a certain number of grams in a pound. 1 pound, so 1 lb there, 1 pound, is 453.6 grams. And that's just the way it is. That's exactly how much a pound weighs. So you can actually convert pounds into grams, grams into kilograms, or whatever you want to do. There's a relationship between miles and kilometers, for example. Alright, there's a relationship between inches and meters, or pounds and stones, and all sorts of different things. So this relationship here, you'll be seeing a lot of these. This is called a conversion factor. And this is important to understand. This is not something that you necessarily need to know off the top of your head, but what you do need to know is how to be able to use something like this. So 1 pound is 453.6 grams. So like I said, you don't need to memorize this, but you got to know how to be able to use it. So for example, let's say we had an introductory question about doing unit conversions, about how many grams are in 25 pounds. Alright. So first off, you have to know what the conversion factor is that you're going to be using, but then you've also got to know how to actually approach the problem. And a good way to think about it is you want to take the question and look at what is the number that I'm given with to begin with. Alright, because that's the number that I'm going to be starting with. So I'm being asked for grams and I have pounds to begin with. Alright. So I can't start with grams because that's what I have to get as my answer. So I have to start with pounds, and I'm going to say 25 pounds. In fact, let's change this up a little bit. Let's say 25.8 pounds. All right, just to give us an extra significant figure. 25.8 pounds. And we want to somehow end up in grams over here. All right, grams. So that requires us to use our conversion factor in such a way as to allow us to eliminate the units we don't need anymore and be left with the ones we do want. Alright. So you'll see that some professors will do something called a picket fence. They'll draw a line and put branches on it, and I suppose I can just do that. I usually do something slightly different, but it gets to exactly the same result. So this is what you start with, and then on each part of the picket fence you put in part of your conversion that you need to do to get to the end. So let's say you have to do, you know, 5 different conversions to get to the final answer. Well, that's just going to be 5 sections of this picket fence. Now this question is not as involved, it's just one step. So we have to wonder, well, I have to be able to write my conversion factor in a certain way. I can either write it like this, I can say 1 pound is 453.6 grams, or I can say 453.6 grams, sorry I should have said grams there, is 1 pound. And for each of these questions you have to know exactly which way you're going to put the conversion factor. And hopefully you can see that in this case it's the way you put it is to cancel out the grams, and if you've got grams on the top here, you're going to need grams on the bottom to cancel that out. So therefore we put our conversion factor in like so, 453.6 grams over 1 pound, and then our units that we don't want anymore will actually cancel out. Alright. Now at this point our picket fence is actually finished. Okay, we don't need to use it anymore, so we can actually just get rid of the rest here. And so all that's left now is just for us to calculate these two numbers, and what this will give us is 11702.88. That's what I get from my calculator. But we also have to think about significant figures too. And here's one other thing we have to be concerned with as far as conversion factors go. You can assume that in every conversion factor you see, you can assume it's got an infinite number of significant figures here, even if it doesn't. This has 4, but for the purposes of our question, you can assume this has 400,000 significant figures, essentially. What that means is, this is an exact number, it's been measured to be exactly this, so this is not something that we're going to be taking into account when we look at significant figures. We always look at the numbers given to us in the question. Alright, 25, and actually we changed that to 25.8. So what that means is, we have 3 significant figures in the question, which means we've got to give 3 in the answer. So we have to report this number to 3 significant figures. So we get rid of that, get rid of that, get rid of that, and essentially get rid of that as well. Well, that doesn't mean we have 117 grams left. What it means essentially is this. Now, if you watch my significant figures video from earlier on, you'll remember that putting these zeros on the end if there's no decimal point is something you want to try to avoid, so put it into an exponential format instead. And so what that would mean is you move the decimal point 1, 2, 3, 4 places to the left, alright? And because this number is bigger than 1, what we get as an answer is 1.17 times 10 to the 4 grams, to 3 significant figures, alright? So that's the basics of how we handle unit conversions. Now what if we have something that has 2 units in the question and we have to convert both? Let's say we have a speed of 125 miles let's see, let's do what should we do? Anyway, let's just say miles per hour, and we've got to convert this into kilometers per second. Okay, so I'm hoping everybody can see at this point we have 2 conversions that we have to do. We have to do one conversion for the time and one conversion for the distance. Alright, now excuse me whilst I'm you might hear some paper rustling around here. I'm just trying to get my necessary conversion factors down, and that's because I know how many kilometers in a mile. Alright, there we go. Sorry about that. Okay, so miles to kilometers. I need a conversion factor from this to this. Each one of you professors is going to be assuming that you can convert hours to seconds. I sincerely hope that that's the case. But the fact is, 1 kilometer is 0.6214 miles. Alright. Again, this is a conversion factor that you're not going to be asked to memorize, it's just something that you need to know. So when we have a question like this, is the first thing we want to think is, well, what do we start with? Well, this is what we start with. We start with the number that we give. So we're going to just write that out. 125 miles per hour. I'm just using MI to shorten miles. And then you want to ask yourself, well, which should I convert first? Should I convert the distance or the time first? Well, it actually doesn't matter which one you do first. Either one is fine. So let's go ahead and do the distance first. Let's get that out of the way. All right. Now I'm going to do a slightly different representation for what's going on here. Here I did the picket fence. Here I'm just doing a series of multiplications, but it's the same idea. So once again, we have to figure out, where do our miles go? Well, if our miles have to cancel out, then the miles have to go on the bottom. 0.6214 miles is 1 kilometer. So at that point, we've converted our miles into kilometers, which is fine, but we've got to get our hours into seconds. Now we can go directly from hours to seconds, but we could get confused. So let's go from hours to minutes to seconds. In 1 hour, hopefully everybody remembers, there are 60 minutes. It's an amazingly common mistake to say 1 hour has 60 seconds in it. For some reason, I don't know why that's such a common mistake. Perhaps because there's 60 minutes in an hour and 60 seconds in a minute. I'm not sure. So in 1 hour there's 60 minutes. And in 1 minute there are 60 seconds. Alright. Now, let's just look at what we have here. And let's make sure we can cancel out all the units that we can and be left with the ones that we know we want. Miles, cancel. Hours, cancel. Minutes, cancel. And notice we're left with kilometers on the bottom, kilometers on the top, and seconds on the bottom. Which is exactly what we want. And then all we need to do is just to go through and multiply and divide. And what I would recommend is for you to calculate everything on the top first, calculate everything on the bottom, and then just put the result here. So we have 125 kilometers on the top, and we have, what is that, 0.6214 times 60 is 2237.04 seconds. And of course we have to divide that out. 125 divided by 2237.04, which ends up being, this ends up being 0.05588 kilometers per second. Now again, we want to make sure we show this answer to the right number of significant figures, and right now we have, what is that, 1, 2, 3, 4 significant figures. So the question becomes, well, how many significant figures do we have to show it to? Well, of course the answer is 3. So we just take this, we lop off the 8, replace this with a 9, we just round up there. So 0.0559 kilometers per second. And that's our answer to 3 significant figures. Alright. Now let's just check that it actually makes sense. Alright, it's always good after you've done a calculation to make sure that the answer does make sense. If you think about it, an hour is a lot longer amount of time than a second, which means the amount of distance you're going to be traveling in an hour is going to be a lot bigger than you're traveling in a second. Although miles and kilometers are different, the difference in time between hours and seconds is much, much bigger, because 60 times 60 is 3,600. Now what that means is the distance you travel in a second is going to be very small compared to the initial number, and that is exactly what we see. So we know that things are okay. Alright, let's do one more of these. I'm going to do one that's a little bit more involved. I'm actually going to do one that involves a calculation of an area. Now, the reason why this is more involved is because we don't just have straight units, we've got square units to deal with. So the question is, how many centimeters squared, how many square centimeters in 150 square kilometers? Alright. Actually, let me just change this again. Again, it's all about, I want to have a couple more significant figures, at least one more. Let's say 156 square kilometers. Well, once again, this is the number that we're going to start with, 156 square kilometers. But now the problem becomes, I know how many meters are in a kilometer and how many centimeters are in a meter, but what do I do about the square business? So let's write out our conversion factors first. I'm assuming that everybody knows in 1 meter there are 100 centimeters, and in 1 kilometer there are 1,000 meters. So the idea is we're going from centimeters, we're going from kilometers squared to meters squared to centimeters squared. That's 2 conversions, therefore we need 2 conversion factors. Okay. So notice this is what we start with, this is what we are asked to find, so our answer is going to have to be in centimeters squared, not anything else. Okay. So first conversion, kilometers squared to meters squared. Well, what I'm going to write out first is the conversion factor that I know from kilometers to meters. And I know that kilometers has to go on the bottom because it's on the top in the original question. So I know that. But at this point we have a problem because we have square kilometers and then we just have 1 kilometer unit here. Those 2 will not cancel, so that means we have to square this. But that means we've got to square this too. So what that means is we have to square everything here. Alright? We're going to come back to this in a minute. Now once we've squared our kilometers and squared our meters, that means I've got meters squared on the top, which means I've got to get rid of meters squared down here. So for this, I'm going to put my meters on the bottom and I'm going to go to centimeters. And I know in 1 meter there are 100 centimeters. But again, because I have square meters here, I've got to have square meters here, which means I've got to square everything. And plus, the only way to get centimeters squared at the end is to square this centimeters anyway. Okay, so what we have here is basically the nucleus of what we need to do to get to our answer. But we can't do anything until we figure out what 1,000 squared is, what 100 squared is, and we make sure that we have it in there properly. So it's always a good idea to write this out again, but with the worked out unit or the worked out number on the top here, because you know that if you square 1 you just get 1. Now 1,000 squared ends up being 1,000,000. So that means in 1 square kilometer there are 1,000,000 square meters. When you square 100 you get 10,000. So therefore in 1 square meter we get 10,000 square centimeters. Now remember what I said before about how we work out this answer? We multiply everything on the top and everything on the bottom and then just divide them out. Notice we're going to have a very, very, very large number on the top here, which is actually fine. That's the way it's supposed to be. Because if you think about it, a centimeter is a lot smaller than a kilometer. A square centimeter is even much smaller than a square kilometer, so you can fit a whole bunch of these inside one of these. So the answer is going to be very, 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 very large. Now you multiply all this out, and what we end up with is we get 1.56 times 10. It's actually times 10 to the 12 square centimeters. Alright? And let's just make sure we can cancel out our units. Square kilometers, square meters, and we're left with square centimeters. Okay? And that, in a nutshell, is the essence of how you do unit conversions. It's pretty simple, so hopefully this video will help you out. Okay, thank you.